want to talk about the application of geometry in real life, which is the atomium and water rocket bottle. And this is our biodata.
Hi, welcome to our presentation. So my name is Jazmiera Ayuni binti Azman. I am 18 years old, Diploma in Science Mathematics, and I am from class 1D.
Hi, my name is Nur Hamizah binti Muhammad Azli. I am 18 years old. I'm studying Diploma in Science Mathematics and I am from class 1D.
The Atomium is a famous building and museum located in Brussels, Belgium. It is an iconic symbol of the city and a key landmark. The structure was originally built for the 1958 Brussels World's Fair Expo 58 and has since become a popular tourist attraction. The Atomium was designed by the engineer André Watekin and architect André and Jean Pollock. The structure is a representation of an iron crystal magnified 165 billion times. It consists of 9 stainless steel spheres connected by tubular structures. The spheres represent an iron crystal's unit cell, and they are arranged in the shape of a unit cell of an iron crystal magnified 165 billion times. The top sphere houses a restaurant with panoramic views of Brussels. The Atomium's design reflects the mid-20th century fascination with science, technology, and progress. Over the years, the Atomium has undergone renovations and has evolved into a museum. Exhibitions inside the spheres covers topics related to science, technology, and the history of the Atomium itself. The building has become a symbol of both Brussels and the optimism and enthusiasm for scientific progress that characterized the post-war period. The Atomium continues to attract visitors from around the world, offering a unique architectural and cultural experience. Okay, so we move on to the Atomium in figures. A series of record in 1958, due to its height, the Atomium is ranked the 60th largest built metal structure in the world. In 1958, it had the fastest lift in Europe. It could carry 500 people an hour at a speed of 5 meters per second, 18 kilometers per hour. Lastly, in 1958, the escalators were among the fastest in Europe. The longest measured 35 meters and could carry 3,000 people per 1 hour. Okay, so we move on to the detail on characteristics of the atomium. So the atomium has 9 spheres corresponding to the 9 atom unit cell making up an iron crystal. The diameter of the spheres is 18 meter. The mass of the spheres approximately 250 tons. The distance between the spheres is 29 meter. And the atomium has 20 tubes. The diameter of the tube is 3.30 meter. The height of atomium is 102 meter. The diameter of the base pavilion is 26 meter. And lastly, the mass of the whole atomium is 2,500 following its restoration in 2006. Okay, so from the detail of characteristic of atomium that I said just now, we decided to make some calculation about the surface area and a volume. of a sphere. So in this slide, as you can see, given the diameter is 18 meter and the radius is 9 meter. So we are using the formula which is 4 pi r square. Then you substitute the diameter and the radius in that formula, and the final answer that you get is 1018.29 meters square. Okay, the next is a calculation of volume of a sphere. So as you know, the formula for volume of a sphere is 4/3 pi r cube. Given the diameter is 18 meter and the radius is 9 meter, when you substitute the diameter and the radius into the formula, the final answer that you get is 3054.86 meter cube.
Next, I would like to talk about water rocket bottles. Water rockets use pressurized air and water in a plastic soda bottle to create thrust. They work by filling the bottle with some water, pressurizing it with a pump, then releasing the air pressure through a valve or nozzle, propelling the rocket upwards. It's a fun and educational way to explore the basic principles of physics and propulsion. The concept of using plastic bottles as water rocket has been around for decades, stemming from the idea of using compressed air or water to propel a bottle into the air. The origins of water rocketry can be tracked back to various inventors and enthusiasts experimenting with simple designs, gradually evolving into a popular educational activity and hobby. One of the earliest documented instances of water rockets dates back to the 19th century when soda bottles were filled with water and compressed air to create propulsion. However, the modern version, often using plastic soda bottles, gained popularity in the late 20th century as an educational tool to demonstrate principles of physics, particularly thrust and propulsion. The simplicity and effectiveness of these water rockets in demonstrating the basic principles of science and engineering made them a common project in schools and among hobbyists worldwide. They are frequently used for educational purposes to explain Newton's third law of motion and the principles of aerodynamics. The history of water rockets is more of a cumulative evolution of ideas and experimentation by various individuals, educators, and enthusiasts than a single inventor or moment of creation. Their continued popularity can be attributed to their simplicity, affordability, and ability to engage people in scientific concepts through hands-on experimentation. Now, we can see there are three launch angle trajectory comparisons. From the diagram, we can see that a launch angle of 45 degrees is the best angle to get the longest horizontal distance. In this situation, we want to calculate the height difference for each angle by using the trigonometric ratios, which is tan theta is equal to opposite side divided by adjacent side. First of all, the launch angle is 30 degrees, while the horizontal distance is 40 meters. After we calculating, we will get the height is 23.0940 meter. Then the launch angle is 45 degrees, while the horizontal distance is 50 meters. After calculating, we will get the height is 50 meters. Last but not least, the launch angle is 60 degrees, while the horizontal distance is 48 meters. After calculating, we will get the height is 83.1384 meters.
So as a conclusion, geometry plays a significant role in our daily lives, impacting various aspects and activities, especially in architecture and sport. Architects and designers use geometry to create aesthetically pleasing and structurally sound buildings and structures. In game sport, understanding angles and distance help in strategic placement on the field or court.
That's all from us. Thank you.